Assalamualaikum warahmatullahi wabarakatuh. Hello friends, I'm Zetta Azzahra. This video explains the altitude of a right triangle using an application, area of triangle. I hope you watch this video until the end. Happy watching! First, let's start off with a problem and you can help me to solve this. My father works as an architect. He and his friends got a job to build a small city park in the shape of a right triangle. Around the park is bordered by a street with a small river that is 6 meters and 8 meters long. The park is divided into two areas using a wooden bridge as a barrier. The wooden bridge starts at an angle of 90 degrees and ends at the very opposite that angle. So, that the wooden bridge is perpendicular to the wall that is opposite the corner. Until now, my father was so confused in determining the length of the wooden bridge. Can you tell me and my father how the length of the wooden bridge? I'd like you to pause the video to answer this problem and then look into my suggestion. Let's see. First, you must sketch off the park to make it easier to solve the problem. The park is a right triangle. So let's say this is our sketch for the triangle. Here the vertex A, B, and C. Suppose the length of AB is 6 meters and AC is 8 meters. Here we are given right triangle is 90 degrees at angle A. Next, see the rules. First, the park will be divided into two areas using a wooden bridge starting at a 90-degree angle. That means the wooden bridge starts from vertex A. Second, the wooden bridge is perpendicular to the wall that is opposite the corner. That means the wooden bridge ends at this vertex. Let's say vertex D. So, we can say the length of the wooden bridge is equal to the length of the side AD in this sketch. Based on this problem, we need to find the length of AD. Before continue to make a solution, do you know the name of segment AD? Or the name of the wooden bridge in a special line in a triangle concept? Yes, the name is altitude. Do you know what is the altitude? Let's see. Consider a triangle ABC. If a segment AD is drawn from vertex A to its opposite BC, such that it is perpendicular to BC, then it is called an altitude. So, AD is one of the altitudes of this triangle. Remember, it only has to be perpendicular to this side. Vertex D may or may not be the midpoint of segment BC. Similarly, let segment BE be the altitude from vertex B to segment AC. Now, if the altitude from vertex C to segment AB passes through this point, we can say that the altitudes of a triangle are congruent. CF be the altitude to segment AB, and we can see that it passes through the point of intersection of AD and BE. All the altitudes of the triangle pass through one single point. Let's name the point O. It's simple. We just draw perpendiculars from every vertex to its opposite side and get the orthocenter. But this was an example of an acute triangle, and the orthocenter is always located on the inside of the triangle. What if it is not an acute triangle? How the altitude and where's the orthocenter? In this video, we just learned about altitude in a right triangle. Let's consider a right triangle ABC and vertex B is a right angle. First, this is the altitude from vertex B to the opposite AC. But what about the other two altitudes? Where does the orthocenter lie? This segment from vertex A to BC is one of the altitudes. This altitude doesn't lie in between B and C. It lies on point B, and this segment is the altitude from vertex C to segment AB. And again, it meets segment AB at point B. All the three altitudes meet at point B. That means, in a right angle triangle, the vertex at the right angle will be the orthocenter. So, the concept of the altitude is a line segment that connects the vertex of any triangle to the opposite side. and that can be extended if necessary. And now, that line segment has to be perpendicular to the opposite side. You can draw 3 altitudes for every triangle, because there are 3 vertices in a triangle, and the orthocenter location of each triangle is different. For a right triangle, the vertex at the right angle will be the orthocenter. We were back to the solution of the problem. We have a right triangle ABC, and we should find the length of the altitude AD. Now, how to find the length of the altitude AD in this problem? Let's see. In such a triangle, we can use area of triangle to find the altitude AD. Now, since this is a right triangle, we know the area of triangle ABC should be equal to a half base times height. And since it is 90 degrees at angle A, the two legs they form base and height. So, we can calculate the area of triangle. As half of we can consider one of them as the base and the other one as the height, right? And let's say the side AC as the base and the side AB as the height. So, a half of 8 times 6 that gives us 4 times 6 is 24. And of course, the units will be meter squared. Now, there is one way of finding the area. The other way to find the area would be area of this triangle ABC will also be equal to a half of BC as the base times height AD, right? We need to find AD, so that is why we can actually recurse the triangle's area using this formula. Now, in this formula, we can always calculate BC from the Pythagorean theorem. So, let us calculate BC. We know BC squared is equals to 8 squared plus 6 squared. Or BC is equals to square root of 8 squared is 64 plus 6 squared is 36. And that gives the square root of 100, which is 10. So, we know the length of BC is 10. So now, we know area of our triangle is 24. It remains same whether you see it from any angle. We can now write 24 as area of triangle ABC, and in this case, we know how BC is 10. And times AD, so it is only unknown which we can now find. Let's cross multiply. So, we get 24 times 2 over 10 equals to AD. 24 times 2 is 48 divided by 10 is 4.8. We can write down our answer that the length of altitude AD is equals to 4.8 meters. So, the last, we can tell to my father the length of the wooden bridge is 4.8 meters. Yay! I hope this video can help you to solve the problem related to the altitude of a right triangle. Thanks for watching. See you. Bye-bye. Assalamualaikum warahmatullahi wabarakatuh.